calculator for today also. Okay, so everything we've done up until this point in the chapter kind of like leads up to these problems. So these problems are putting everything together. We are trying to solve a polynomial. So if it's a quadratic or a linear equation, we know how to solve those already. Like quadratic, we always have quadratic formula, but once it gets bigger, cubic, quartic, something like that, unless it's factorable, we can't solve it. So we have other methods. This method is involving with the rational roots. So you guys did that yesterday with the P's and Q's, where you find all the list of possible rational zeros, meaning zeros that can be written as a fraction, and we use that as like a base of numbers we can start with. From there, we're going to narrow down the list by graphing in our calculator. Back in the day, before people had graphing calculators, they just had a long list of P's and Q's, and they started dividing things in until something worked. If you have a large list of P's and Q's, like 36 P's and Q's, we don't have time for something like that. So we use our calculator to narrow it down. Every time, yes? Yes. Somebody's charging theirs over here. Okay. Our goal is to be able to divide numbers into this polynomial to get to a point where it's at least a quadratic that's left, and it's going to get smaller by 1 degree every time we do division. Once it's a quadratic, then it's something that's solvable. The degree of your polynomial is going to be the number of solutions you should get. So this is a degree 3 polynomial. I should expect 3 solutions. In section 3.4, all of the solutions we're going to get are real. In section 3.5 that we're going to do tomorrow, some of them will also be imaginary, but there should be the degree and total solutions all put together. All right, so here's how this works. First step is we're going to list all of our possible rational roots, P's and Q's. And these are what the instructions are going to look like on a test or a quiz. So you need to make sure you're showing these steps. Okay, so P's from yesterday's lesson come from the last number. What are factors of 8? Things that multiply to 8.
1, 2, 4, 8.
Perfect. Q's come from the first number, 2. So factors of 2 are 1 and 2. Then we make our rational roots list, P's over Q's. In front of each of these, put a plus or minus. All right, so I'm just going to take my first P and divide it by all the Q's, and then my next P and divide it by all the Q's, just so I don't miss anybody. If something happens more than once after you reduce the fractions, you do not have to list it more than once, as long as it's in the list somewhere already. So P over Q, 1 divided by 1 gives me 1. 1 divided by 2 gives me a half. 2 divided by 1 gives me 2. 2 divided by 2 is 1. It's already on my list. 4 divided by 1 gives me 4. 4 divided by 2 is 2. It's already on my list. 8 divided by 1 is 8. 8 divided by 2 is 4. It's already on my list. Okay, so really here, how many possible rational zeros do I have? More than that. There are 10, including all the pluses and minuses. I have 10 possible rational zeros. So again, back in the day, people would just take this list of 10 things and start dividing it until something worked. We're going to narrow it down better with our graphing calculator. So what I want you to do is go to y equals, and I've got a couple equations here, but just type in this equation in y1. Okay, so 2x cubed plus 3x squared minus 6x minus 8. And we're going to get a graph of it. You can just graph it in your standard window. Oh, that's a minus 8. Hold on. I typed mine in wrong. Minus 8. Yeah, it looks better. Fix it. Okay. Everybody get something that looks like that? All right. So what we want from this graph is we want to compare our P over Q list to my zeros, my x-intercepts. P's and Q's are possible zeros. So We're looking at these fractions, these whole numbers, and deciding, could any of those numbers be x-intercepts on this graph? So, like, for example, for this one, I would say it looks like x is approximately at -2 there, okay? The other ones, I mean, maybe -1. The other one, the closest it's going to get to is 2 on my list. Okay, again, those are just estimations. This helps us figure out what to try to divide first. Out of those 3 numbers, which one are you most confident about that it actually is an x-intercept? -2. Okay, so after we've graphed it, our next step is to use synthetic division. You could use long division, but synthetic is faster. So we're going to use our original polynomial, 2, 3, -6, -8, and you're going to pick whatever number you are most confident about. So I'm going to use 2, or -2. If it doesn't work, and I know it won't work, if I get anything other than 0 as a remainder, I just erase it and I try a different number. So there's a little bit of trial and error here. The graphing calculator hopefully gives us a good direction at least. So we want a 0 remainder. Let's see. Bring down my 2, multiply -4, add -1, multiply 2, add -4, multiply 8. I get a remainder of 0. Okay, so as far as answers go, -2 is my first answer, for sure. There are 2 other answers because it's a degree 3 polynomial. How I get the other 2 answers is I'm going to use the quotient here. So the quotient, if I start out with a degree 3 polynomial and did synthetic division 1 time, is now a quadratic. It's degree 2. Remember, the degree is 1 less than what I started with. So this means 2x squared minus 1x minus 4 equals 0. And now if I solve that, I get my other 2 answers. Most of the time, these are not going to be factorable, I'll warn you. So if you see something like this, I would just go probably straight to the quadratic formula to get my other 2 answers. X equals, opposite of b is a +1, plus and minus square root. B squared is +1, minus 4 times a is 2 times c is -4. All over 2 times a, 2 times 2. So I get 1 plus and minus, what am I going to get under there? 33 under my square root over 4. Does square root 33 reduce? Does a perfect square divide evenly into that? No, it's a prime number. So those are my other 2 answers. 1 plus rad 33 over 4. And 1 minus rad 33 over 4. Now, here's how you can check that those answers make sense. If I type those in my calculator, if I do 1 plus the square root of 33 and divide by 4, I get approximately 1.686. That's if I use the plus. And if I use the minus, 1 minus square root 33 over 4, I get -1.186. Now, those should not be written as answers on a test or a quiz because they're not exact. But look at the other places it was touching the x-axis. Do those numbers make sense for those other 2 zeros that we see that weren't quite integer numbers? So that's how we know we're good on those, okay? So if you don't get a nice pretty number, look at your x-intercepts and see if those are reasonable for where you're seeing it's crossing the x-axis. Questions on this process? All right, so really nothing new here. We're just kind of like putting a few different ideas together. So we're going to do one more together, and then the third one I'll let you guys try on your own. Let's try this one. Find the real zeros of 3x to the 4th minus 11x to the 3rd plus 22x minus 12. It's a degree 4 polynomial, so we expect 4 solutions. All right. P, Q, P over Q. All right, what are my values for P? It's going to be multiples of 12, or factors of 12. 1, 2, 3, 4, 6, 12. Yep, okay. Q, factors of the leading coefficient 3 are 1 and 3. P's and Q's, plus and minus. 1 over 1 is 1, and 1/3. 2, 2/3. 3, 3/3 is 1. It's already on my list. 4 and 4/3. 6, 6/3 is 2. It's already on my list. 12, 12/3 is 4. It's already on my list. Okay. So now, because we have technology, we use it. Go ahead and graph that in y equals. I'm going to edit mine to show up the other one here. There we go. All right. If you had to pick numbers from that P over Q list that you think could be x-intercepts, what would you guess? 3 looks good. Anybody else that we want to add to that list? 4/3. Anything else? We might need a few. -2. What else? I think we can be more exact with that one, actually. -4/3 might be a little closer. And then what about between 0 and 1? Maybe about 2/3? Okay, we don't know. We're just guessing, but they're maybe close to those. Okay, if you were most confident about one of those, which one are you going to be most confident with? 3? Okay, so be careful with your synthetic division here. 3, -11, 0, 22, -12. Why do I need a 0? Because there's no x squared. You will, on a quiz or a test, bang your head against the wall because your synthetic division won't work if you don't put that 0 there. You will get very frustrated. Always look for the zeros. All right, let's try 3 first. If it doesn't work, we'll try another number. No big deal. Let's hope we get a 0 remainder. So we're going to bring that first number down 3, multiply 9, add -2, multiply -6, add -6, multiply -18, add 4, multiply 12, add 0. Good. Okay, so final answers, x equals 3 is an answer. I'm missing 3 more of them. Now, if I did synthetic division one time and I started out with a degree 4 polynomial, am I able to solve it? Not yet. It's a degree 3 polynomial. So, I mean, we might be able to get lucky with like factoring and stuff, but most of the time you're not. So we call this guy, if I put the x's back in, 3x to the third, so on and so forth, we call it the depressed equation because it's smaller than the equation we started with. So when you get into Math Excel, it'll say, divide this out and then use the depressed equation, da, da, da. It just means keep going with that, okay? Don't go back to the beginning because you want to make it smaller and smaller each time to get to that degree 2, to get to that quadratic. So now, pick another number, and we're going to synthetically divide it into those values. What else from my list? I got to use something with a fraction. -4/3. All right, a little more room to write that one. And again, if it doesn't work, we'll just try something else. No big deal. All right, bring my 3 down. What's 3 times -4/3? -4. Plus -2 is -6 times -4/3. +8. Plus -6 is 2. -8/3. Is that going to give me a remainder of 0? Nope. -4/3 doesn't work. This is why we do math in pencil. All right. Pick another number. 1 is not an option in my list. I mean, you can try it. It's not going to work, though, I promise you. 2/3. Let's try it. Bring my 3 down. 3 times 2/3 gives me 2. Plus -2 is 0 times 2/3 is 0. Plus -6 is Negative 6 times 2/3 is negative 4. There we go. 0. All right, so 2/3 is my second answer. How many more answers do I need? 2 more answers. Okay, but it was degree 4. I did synthetic division 2 times, so that brings my degree down to a 2. Now I can put the x's back in. This is a 3x squared, a 0x, which I'm not even going to write, minus 6 equals 0. Do I need the quadratic formula to solve that? No, because there's just an x squared. So let's just get it alone and use square roots. Add 6, which, by the way, you can use a quadratic formula if you want to. Your b value would be 0, but it's going to take a whole lot longer, so I'm not going to do that. Add 6. Add to 6. Come on, computer. Divide by 3. Come on, computer. There we go. X squared equals 2. So what does x equal? Plus or minus square root of 2. So positive square root 2. Gotta write really slow because my computer's lagging. And negative square root 2 are my other 2 answers. Now, if you type square root 2 in your calculator, it's going to be like 1.4 something. So does that make sense with those other 2 that we don't have? About negative 1.4 and about positive 1.4? Or we're crossing the x-axis, and then we had 2/3 and 3. We already accounted for those. Questions? Yes.
Like when you write it out like square root 2, negative square root 2, can I just keep it plus or minus? Or do you have to-
I don't care about that. Like test or quiz, Math Excel might want you to do this, so let's write it like that.
Can I use synthetic division to find every single x?
No, because you won't know that square root 2 is a 0. You only from this P and Q list are going to get rational answers. Things can be written as fractions. So we have to do this whole process to get these irrational solutions. So I promise you on a quiz or a test, there will not be all rational zeros as answers. You will have to do, and it'll say in instructions, use rational roots and synthetic division. So, yeah. Yes. Yes.
Can we find the zeros on the calculator like we do?
So you can in the calculator do that, and it's going to tell you it's 1.41, it's not going to tell you square root 2. It's not going to give you exact answers.
Can we find it for like the one that needs 3 and 2/3? Can we find something?
Yes, but without synthetically dividing those out, then you won't be able to get the positive square root 2 and negative square root 2. So you could do that in the calculator to avoid like extra synthetic division. Like if you want to calculate it and see it's 0.6 repeating, okay, 2/3, I know I need to divide that one. Is it worth the time? I don't know. I mean, that's up to you. You have to kind of decide if that's something you want to do or not. Okay. All right. So you guys are going to try one on your own, and we're going to put answers up on the board here. Now, this is a 5th degree polynomial. How many answers do I need? 5. How many times are you going to have to do synthetic division to get it down to a degree 2? 3 synthetic divisions in this problem. So that means when you estimate off the graph, find at least 3 numbers that you think will work. All right, so go ahead and work together on it. I'll give you a few minutes, then we'll put our answers up on the board and check them. All right, let's see how you did. I circled the 5 answers. Now, you guys may not have done your synthetic division in the same order as me, and that's okay. So like this, these numbers in the middle might look a little different because you're factoring out things in a different order, but you still end up, once all 3 are factored out, with these same numbers at the end. Okay, and as long as you're getting 0 each time, life is good. And then this one you don't need quadratic formula for. Square root of 3 is about 1.7. So positive 1.7, negative 1.7 are the extra zeros you're seeing on the x-intercepts there. The x-axis.
Is this where we get our graphing calculator for test?
You will get your graphing calculator for 1 day of the test, yes. And then basic calculator for the other one. Oh. I don't need to put things in. No, I'm good. I gotta talk more. I'm okay. Talk with a sucker in my mouth. You think so?
I don't know.
What questions do we have on this? Anything? All right, we just have one more theorem, and then we're done. So let's wrap it up. Okay. So this is called Descartes' rule of signs. So this theorem was more so used back in the day before people had graphing calculators to figure out how many zeros we could potentially have that were real, were x-intercepts, okay? So there are two parts to this theorem. The first part of this theorem says the number of positive zeros, okay? So that means guys that are on the right side of the x-axis, positive numbers, is equal to the number of variations of sign or less than that by an even integer. Now, when we say variations of sign, we're looking at the actual equation itself and just counting how many times it changes from negative to positive or positive to negative. That's the number of variations of sign. When it says less than that by an even integer, it means take that number and keep subtracting 2 until it basically doesn't make sense anymore. So let's say I had like 5 variations of sign where it changed from positive to negative or negative to positive. This theorem would say, okay, that means there are either 5 or 3 or 1 positive zeros. Okay, and then we use synthetic division and things to narrow it down more than that. I know not to subtract more than that because I can't have a negative amount of something. So we either stop at 1 or 0. Let's say I had 4 variations of sign. My answer would be 4 or 2 or 0. So you just keep subtracting 2 until it doesn't make sense anymore. Second part of the theorem is how we find negative zeros. The only difference is instead of using the original function, we use the one where we plug negative x in. We've done that before when we did like even and odd stuff. So again, it's number of variations of sign, but for f of negative x or less than that by an even integer. Okay, so these problems will be really specific. You are not actually finding zeros. You are not solving for them. It's just how many could we have? And it's going to say directly in the instructions, use Descartes' rule of signs to find the number of positive zeros and the number of negative zeros. All right, we'll practice this on the next slide, and then we'll be done. All right, so we're going to do the next one together. Write down this function f of x equals x to the 5th minus 3x to the 3rd minus 5x squared plus 9x minus 7. And the instructions say find the possible number. So we're not actually finding them. We're finding how many of them we have of positive and negative zeros. Okay, so 2 parts to the rule. First part of the rule, we find the possible number of positive zeros. All we have to do in the equation is count from left to right how many times the equation changes from positive to negative or negative to positive. And your terms need to be in order, which usually they are for these problems already. All right, so my first term is positive. My second term is negative. So between the first and the second term, there is a change of sign. The second term is negative, and the third term is also negative. That is not a change of sign. Negative to positive, change of sign. Positive to negative, change of sign. So as I read it from left to right, 3 times it changes from positive to negative. So that's the first part of my answer, 3 or less than that by an even integer. So just keep subtracting 2 until it doesn't make sense anymore. So 3 or 1. Should I subtract 2 again? No, because it doesn't make sense to have a negative quantity of something. So they're either 3 or 1, positive 0. So what does that mean? It means if I looked at the graph of this function, on the right side of the x-axis, there's either going to be 3 or 1 place where it crosses the x-axis. So that helped people back in the day kind of like narrow down how many I should be trying. If I have 2, I know there's got to be a third one, that sort of thing from that big list of P's and Q's. All right, then before we do the negative zeros, we need to evaluate f of negative x. So this is where we plug negative x into the function for all the x's. Make sure you put it in parentheses. And we simplify. Will the first term be positive or negative? Negative. Will the second term be positive or negative? It's going to be negative x to the third is negative times negative 3 is positive. Negative x squared is positive times negative 5 is negative. You always do the exponent first. Minus 9x minus 7. How many changes of sign are there? First to second term is a change of sign. Second to third term is a change of sign. After that, it remains negative. No more changes of sign. So the possible number of negative zeros is 2 or... Should I subtract any more? No. Final answer. Okay, so we're not finding the zeros. It's just how many of each of them could there be. All right, you guys do the second one, and then we're finished. Find the possible number of positive and negative zeros for that function. These are pretty quick. Did you get it?
Yes.
Yes?
Oh yeah.
Positive zeros, there's just one. Negative zeros, there are either 2 or 0. Any questions? Descartes' rule of signs. All right, so 3-4 Math XL. This Math XL assignment is due on Monday night. Was your 3-3 due already?
Yeah.
That one's done? Okay, so the next one you're working on 3-4 is due on Monday night. Your calendar that I had given you guys, I think only went up through the end of October, so I've got November here for you. The end of next week is our next test. We only have 2 more sections, 3-5 and 3-6. 3-5 we're doing tomorrow, 3-6 beginning of next week, and then we're getting ready for our next test. So I wanted you to have this calendar so you can kind of see what's coming up. There you go.
I don't need a calendar.
You don't need a calendar.
I just listened to what you're saying.
Yeah. Yes.
I don't know what to do. All the stuff done. I don't know how to
Maybe.
What's the app here?
I would just do all the things that tells me to do. The app is like Microsoft
I also have a question about.
Yeah. Uh-huh.
So like, how do you know like when it's like the or like it's like.
So this one won't be 0. It's only less than that by a minute.
Oh,
You
okay.
can't
Yeah,
keep track where you want, you just track where the number is. So, one, you can't subtract 2 anymore. We don't say that.
Okay. Yeah, I just know it's inside.
That's evil.
It didn't tell me that.